Please welcome our moderator, the New Stack's founder and publisher, Alex Williams, and panelists, IDT CEO, Margherita Ferragatta, Ampere Computing's Chief Evangelist, Sean Varley, and Canonical's Head of Software Partnerships, Aniket Ponkshe.
Out on the big stage now, so excited. Hi everyone, I'm Alex Williams, founder and publisher of the New Stack. We're a media publication. We focus on at-scale development, deployment, and management through really explaining stuff and analyzing stuff as best we can. And our audience are software engineers and developers, so I feel right at home here today. And so why don't we have you all introduce yourselves. Margherita?
Yeah, thank you, Alex. Hi, everybody. I'm Margherita. I'm CEO at IDT. IDT is a tech company that was founded in Turin with the idea of bringing open source hardware and software solutions in the world of industrial automation. So we were born as system integrators. Let's say that the world of industrial manufacturing has always been filled by proprietary technologies, full of licenses and royalties. So what we're trying to do is to do something different. So whenever it's possible, we try to make our clients avoid what is called the vendor lock-in, let's say. So that's why we're long-standing Arduino partners, as Fabio told you before. And yeah, so we started out mainly in the automotive industry. So we end-of-line solutions and continuous improvement projects, as you'll see afterwards.
Aniket.
Hi, I'm Aniket Ponkshe. I run our software partnerships here at Canonical in the Americas. A lot of you will have heard of Ubuntu. Canonical is the company behind Ubuntu. We are super developer focused with a huge ecosystem of folks who run Ubuntu today, whether it's on the cloud all the way to edge and IoT. We have tailored products for each of those verticals that you see there. And then I think most importantly for this, we are sort of the de facto operating system for AI everywhere. And a lot of AI is open source. So we like to think it starts with us.
Way to go. Sean.
Yeah, thanks, Alex. Sean Varley, I'm the Chief Evangelist for Ampere Computing. Ampere Computing is about a 7-year-old company, 8-year-old company, and we focus on sustainable compute and more specifically AI compute, which means that we build processors that are probably orders of magnitude more powerful than what you just saw on the stage previously. But that's kind of all fitting into a much larger ecosystem where AI now is changing the way all things are done in computing. And so what you see here is our kind of product lines from 32 cores all the way up to 192 cores. So really server class, but also now being pushed to the edge, and we'll talk more about that.
Well, great. Well, one of the real interesting aspects of Edge AI today is the overall ecosystem. I think that's really the best context for us today. And I was thinking about this a little bit before the conference, and thinking about it as a hardware layer, the operating system layer, the platform software layer, and the application layer. And Sean, when I heard Zach Shelby talking this morning, I really thought about this question in relation to what you do over at Ampere. And he talked a lot about how in 2017, TinyML started, but it was like all these tools that were available for machine learning were just really not appropriate for edge environments. Can you take us back to that time for you and Ampere and how those technical hurdles have lowered and what that means for use cases today?
Yeah, absolutely. It's a really good question because, what you got, if you go back in time to really the early roots of ML, it was really kind of constrained by compute in a lot of ways. And so, models were much smaller than they are today. And what you see is that as computing was kind of growing, and you heard Quaban, I hope I didn't get your name wrong, talking about NPUs in small packages. All of that compute getting kind of integrated into large scale, VLSI type of ASICs and standard, kind of products has changed the entire game, right? So now you can do things like YOLO in a very small device. But you can also do a large language model with over 1 trillion parameters in CPUs and GPUs and other accelerators. So that kind of progression from 2017 to now, present day, it's not been that much time, right? So all of the open source and the frameworks and everything else had to change along with that. You know, I have a very distinct impression of how the hardware's changed, but everything in the chain that you mentioned has had to change along with that.
And so, Aniket, I recall Ubuntu being really at the forefront of edge AI or edge environments back in the, you know, dating back to even the 2014, 2015 with Ubuntu Core. By 2017, we started seeing new lightweight Kubernetes distributions emerge. And that really, I think, helped position Ubuntu, didn't it? You know, to be able to establish itself with Ubuntu Core moving forward. And I know that you just had some recent announcements, you know, as of last year. I'm curious on like that time frame for you and what you saw emerge, you know, as you were like getting Ubuntu Core into a state of a better maturity.
Right. So I think Sean touched upon this, and you also mentioned there's foundational problems when you think of edge AI that are different from AI in the cloud or AI on your normal desktop stack, right? One is the people, the set of embedded developers who were, you know, brought up with Yocto or kind of roll your own Linux is distinct from people who are cloud native and are running on Kubernetes and, you know, TensorFlow and PyTorch and all of that, right? That's one. The second is the stacks themselves can be different. So when you look at the software that's being deployed versus what you're training on, that's going to be somewhat different. And then security is a third thing that comes in, where now the default expectation that enterprises have is increasingly that the same level of security which was applied to the cloud and the data center is now available at the edge. And our kind of story is, yeah, you can use Ubuntu on the cloud and you can use Ubuntu on the edge. What that's going to let you do is accelerate your development to deployment cycles by far. So you're talking weeks, not quarters. When you think of new models coming in, very rapidly you can reach that time to market, time to value. And that goes up the stack. Like we have deep integrations with things like Kubeflow, MLflow. So we can actually run an entire open source cloud for your training and then deploy it at the edge with things like Kserve.
So we've heard a little bit about the hardware environments, the operating system environments. I'm going to put the framework environments on hold a little bit and go straight to application layer for Margherita. And the discussion about Arduino this morning really opened up my eyes to kind of where you were all at the time. And you were telling me beforehand that this was kind of an interesting time for you back in 2017 or so when your company was just getting started.
Yeah, it exactly happened like the same thing to us, but like at the application layer. So when we started out using Arduino technologies, like we wanted to use open source technologies, but it was back in 2016, 2017. We actually met with some Arduino guys on the train. It's how our partnership started. But their solutions were not industrial ready. Like, let's just think that Arduino Pro, the business line, was born in 2020. So yes, it was quite difficult for us at the beginning to start because we wanted to use open technologies, but not many hardware open technologies were ready for the industry. So we had to do lots of partnerships and we had to do lots of developments and integrations. And then Arduino came out with some industrial ready solutions. So yeah, that's how we started. That's how our story happened, and I think one of the biggest successes was that then in 2022, I think, we managed with their solutions to carry out what you're seeing on the screen. This is a pick-and-place application of handling the battery cells of hybrid cars of a big Italian luxury automotive company, let's say. Like Zach hasn't said anything before. And so yes, in this case, you can see two Kuma robots on the screen, and everything is handled by two pieces of Arduino hardware, and even acting as cross-link, one with the other, to handle the communication between the robots. So yes, I think that's our greatest achievement.
That's really interesting. And Sean, when we think about the specialized chips today, and what they provide, how are they impacting use cases now How are you seeing that?
Yeah, we're really in a gold rush of sorts, right? You see AI creeping into every aspect of life, going from hyperscale data centers all the way into the edge, through the networks, right? Through the distribution networks. Previously, you probably saw up on the screen some of the telco changes that are happening, because telcos are starting to leverage their position in proximity to users, right? To start to put forth infrastructure that can then process AI. But that's also going all the way out to the edge. So here you see intelligent video, kind of recording platforms also changing. In fact, the OpenMV, that you just saw earlier in the previous presentation is very similar, right? It's just that the AI is happening at the camera, but there's a lot of aggregation, and AI can happen in layers. It happens in the device. It happens as a backup in the cloud or at the edge of the cloud, and all the way back up into hyperscale data centers. So all these use cases are kind of blending, but also have their own unique segments. But I think what's really interesting about this is the level of integration of different technologies, because in everything that you do with AI, it comes with a power penalty or cost, right? And so you hear a lot today about, the data centers needing small form factor nuclear reactors and things like this, right? But that same paradigm is happening at the device layer, right? You're trying to fit things into small form factors, right? On batteries. All that stuff is changing radically the silicon that's being designed to be put in those devices, but also, what type of optimizations can we create through the application layers, the OS layers, the size of containers and things like that. The size of the model itself has a huge, huge impact on the actual footprint of the hardware.
So Aniket, when you're thinking about these new emerging use cases, what are some of the trade-offs that you're starting to see? What are some of the forward-looking thinking that you're having to consider when you're thinking about, the market's not quite ready for this, but there are these use cases that are evolving, that are still not quite mature. How do you kind of consider those trade-offs yourselves?
In terms of, everything's changing, right? Like the technology is moving so fast with the models evolving every month, every quarter. As I mentioned earlier, security is a key dimension that comes along. Chips are getting faster every year. What that is enabling is a whole bunch of new use cases that were really hard to implement or impossible to implement before, which can lead to real business outcomes. So I think on the slide I have many. I'll pick Asina to start with. Asina is the brand behind Ann Taylor, for those who shop for clothes in the US. They use our open source ML stack to implement a real-time recommendation system that can give customers choices at the point of sale. And they actually had measurable business outcomes of 10% more cost of sale once they actually implemented the solutions that can let you go to market faster. Similarly, we had Duke Energy and others in that space do real-time load balancing of, when your windmill is generating electricity, it's not doing so at the same rate every minute. So as soon as the wind stops, you have to load balance and say, oh my God, I need more power from this other network. All of that's real time, all of that's AI. These are things that you couldn't easily do even 3-5 years ago that people are starting to put into production in the coming time frames. I could go on, but.
Right. We've talked again about the hardware layer. We've talked about the OS layer and the application layer. Perhaps you could talk a little bit as well, just a follow-up question to what you're saying about models, with these frameworks. We're talking about millions of developers that we're trying to get to start using edge environments. I think 1 million what is the initial goal. I'm curious on, what kind of models can now be deployed, and what kind of use cases are they allowing across different hardware configurations?
Is that to?
Either one of you, yeah.
I could take a crack at it. So coming back to where I kind of ended that last set of comments, so the size of a model makes a huge difference on where you can run it, right? So if you're running a really large size parameter model, maybe hundreds of billions of parameters and things like this, then you can't fit that into a small scale processor like we were just looking at. You have to fit that into a GPU, or in many cases multiple GPUs, to be able to run that kind of a model. And let's forget a trillion parameter model. This is kind of large scale, rack scale, kind of computational horsepower needed. So the framework that you're going to use to be able to deploy these models matters a lot, because the framework now has to not only just compute the model, but it has to be optimized to run on a specific chip, right? Or a specific architecture within that chip. And those things require intelligence, right? So what you see happening is this level of intelligence is starting to kind of hone in on a size of a model that's most appropriate for the specific use case, but then also optimizing for the chipset that it can land on. And all of that intelligence is filtering all the way up through the frameworks and into the orchestration layers.
Yeah, to add to what Sean said, Pabena talked to it earlier as well. Like, you were talking of tens of thousands of point-of-sale systems in the past. Today, you're looking at millions and millions of sensors out there that are all sending you back the data. And it's becoming important that you right-size your AI story. So does your data have to necessarily go to an expensive cloud, adding latency, adding cost? Or can you actually process it close to where it's being produced and send the analytics back up to a larger scale system? So right size.
When we're talking then about automotive environments and talking about where you're seeing the industry today, are they ready for edge AI? Is it all they're talking about in the automotive industry? Kind of what is the state of things in the automotive world?
So it's quite hard still. So when we started out, it was hard to implement open technologies, and now it's still hard. I mean, sometimes people change the tech specs, but still they do that only when they want to have like some trade-offs, when they see that, okay, I cannot have everything that I had in the past, or like, okay, I can also try something new. And as Aniket said before, I think one of the main reasons why this happens is the time to market. So very often, like new solutions, open solutions, or like edge AI offers, like an edge impulse solutions offer like a lower time to market. So that's something like that the client starts reasoning about. Second thing why they might choose to try like edge AI probably I think is the fact that there are so many latencies if you only rely on connectivity on clouds, on servers, especially in industrial plants, in the manufacturing. Like it even happened to us once that the client didn't allow us to use their Wi-Fi connection or their Ethernet ports. So in this case, like you're stuck. If you don't have some offline functionality that can guarantee continuity to the production, you're stuck, because as we were talking about yesterday, even like reaction times in a production environment and in the automotive even more like need to be deterministic. So they cannot just be left like, and sometimes it's really a matter of milliseconds. So the more you have in terms also of offline functionality and communication with the PLC and everything, I think the more the better. And yeah.
So Aniket, I want to go back to you, and then we'll go to Sean with some few last questions. Then we'll conclude with Margherita. But can you talk to me about what you're seeing as what is attracting developers to edge environments? What are some of the trends that you're seeing with the developer community, and how what is like bringing them to think about edge more in their work?
Right. I think one of the big changes that our partnerships with the silicon makers have caused is standardization of a platform that is setting the stage for you to focus on your application development rather than worry about, oh, does my OS boot, right? So we have a full supply chain story with Advantech as an example, Thundercom's another one, where you're time to actually start working on your story has reduced a lot, and developers really appreciate that. They get the same cloud-like environment that they're used to with the Ubuntu, but it's optimized for the features of the silicon that they're running on, which is a fantastic story. The same set of applications, Kubeflow comes to mind, Keras comes to mind, TensorFlow, all of those which were natively running on Ubuntu, guess what? They're now available to you at the edge. And that causes this explosion of new ideas, of new products that you can actually build in a much faster timeline that makes it economically viable to do that. And all of that's backed by the same 10-year LTS guarantee that Ubuntu comes with.
And Sean, a lot of this gets very complex at the hardware layer. You have to think about a lot of different factors. I mean, the amount of engineering that's being required. Maybe you could provide us some insights into how you're thinking about the overall infrastructure of these edge environments in terms of the storage capabilities, the in-memory capabilities, the networking capabilities, and where are we now? And what are you seeing coming next?
Yeah, I actually made a prediction at a conference earlier this year. Most in the past, computing was measured by some kind of esoteric performance benchmark, that you had to sort of be insider to understand and stuff like that. But my prediction is that all compute in the next several years will start getting measured by power. How much power does it consume? And it's going to be able to process AI, right? So because AI has such a power tax, you will start to see processing classes be built according to how much power they consume. And so you'll see these really micro power watt, watt devices, and then you'll see large scale, hefty rack scale modular architectures. And all of those things will come with their associated power tax. But how that kind of translates, I think, to what you're asking is that, people that consume them will also be looking at a number of other parameters that are important to their use case. If I'm processing vision, you saw frame rates, right? You saw resolutions, you saw things like that. In LLMs, you might have a situation where you're looking at, okay, how many languages do I need to recognize, through spoken word? All these different parameters will kind of, again, dictate the size and configuration of those models. And then those models will start to be able to be processed by a certain amount of power, right? And so all of that will kind of, I think, naturally gravitate to create markets, right? And I think that's one of the biggest things I think we'll see simplify the complexity of all of these different layers that are kind of in AI now.
Yeah, and so downstream then at the OS layer and the distro level, how does that impact how you think about, the workloads that users will be wanting when they, see what's coming available, on these specialized hardware environments?
Right. It's a very good question. I think, to your point of power, there's different form factors that are somebody's going to sip power, somebody's going to gulp it when you're training really high power stuff on NVIDIA DGXs, for example. We offer different ways to reduce the footprint of your base container and your application itself. So if you're on the cloud, we offer a technology called Chisel, all open source, by the way. You can go play with it. To reduce a deployment, I think one of the examples was with Microsoft.NET, where the container went down from 200 MB to 50 MB. So that's a significant reduction in everything. Boot up times, power consumption. Security is much better because you're securing a much smaller footprint now. On IoT, you have Ubuntu Core, where it's security first containerized app, kind of like your phone app, but for your IoT device. And that's much smaller than what a traditional Ubuntu would be. And we have some other stuff coming for devices that are even smaller, which would be very exciting to this audience, but can't talk about yet.
So that gets to my question for you, Margherita.
Okay.
And you work with these automobile companies, and I expect they're a pretty ambitious group of people. So what are you hearing from them about what they really want? And how does that impact, like, for instance, your application wish list, so to speak?
So first, let's talk about like what they want. And what they want, I think, is to have flexibility and to really like use operators to give like to their products like added value, because there are so many operations that are carried out that don't bring added value to the product. So I think that a real shift where like AI comes in and everything we talked about comes in is the shift from Industry 4.0 to Industry 5.0, where flexibility is at the center, there is a human centricity, and AI can really help the operators in the lines. And then if I have to talk about my wish list, obviously, I mean, our company mission is we update standards thinking out of the box. So obviously, my wish list starts with the idea of like not having to struggle to bring open technologies and edge AI in industrial automation and in industrial manufacturing. So, but having the clients believe that the solutions are actually reliable and they can guarantee product continuity.
Okay, so we have a little bit of time left. So Sean, Aniket, I'm going to ask for your wish list based upon what you're hearing from customers. What would you think they would be wishing for at this moment, which they would see so they could take on this next generation of use cases? Sean?
Well, everybody wants a lot of horsepower in as little power, actual electricity as it can get. But the state of the industry is such that we actually try to rise to meet these occasions, right? And so what you see happening is that a lot of us are stretching to put kind of capabilities into smaller and smaller packages. And in our case, in Simon Semiconductors, our packages are measured in centimeters or millimeters. And so the industry is kind of starting to rally around this idea of being able to take and mix and match functionalities. Right? We like to call it heterogeneous computing, something that does a little bit of AI acceleration, a little bit of general purpose processing, maybe some sensor, some communications. You mentioned storage earlier. All these things are going to be combined into more and more complex SoCs going forward. And I think one of the things to kind of draw it back to our hosts is that the platforms, right, the frameworks that can actually translate that to developers, as Edge Impulse does, is a super, super powerful combination.
Yeah, and Aniket, that's the kind of question I was going to ask you just in conclusion, is about the developers, what they're really wishing for. I mean, I imagine it's all those kinds of things that Sean's talking about, but from your perspective, in terms of what you're seeing out there, what would you say they'd be really wanting to see over the next 12, 18 months?
I think one theme is definitely the amount of data that people are generating. And there's increasing awareness of like who's owning that data. Like, can you really transfer it to the cloud, or would you rather have control on it yourself? So I definitely see that processing getting pushed more to the edge, where the creator, generator of the data actually has more control on how it's consumed and monetized. Security is another very thought out feature, because nobody likes to be, I think like the latest one is Jaguar Land Rover, where their IT systems are down, and it's down for many months now.
The cost of that.
And there's regulation coming in that's going to change how we think of these industrial factory settings, or even inside the car. And that's going to be a new world we'll be living in 5 to 10 years.
Well, that about concludes things. Our time is up. I want to thank Margherita, Aniket, and Sean. Thank you very much. And thank you, everyone, for being here. Really appreciate it. They're available to chat if you want.
Thank you.